Okay, so do we agree, or let me ask you guys, think. So are the two figures similar? Yes or no? Why or why not? Sayla says yes. Can anybody else back her up, or? Yeah, okay. Can anyone explain why? Why are the two figures similar? Because they look like it? No. Yeah, yeah. He says figure A is twice as small as figure B, right? But does that have anything to do with their side lengths? I agree with you, but does that have anything to do with their side lengths? Okay, yeah. What do you think? It's a square. They all have the same. Okay. What is the side length of figure A? 2. What's the side length of figure B? 4. Is that happening? Is that ratio? What's that ratio? 2 to 4, right? Okay, so we're going to write that down. So over here on the left-hand side, notice I have the ratio of their sides, and then we're going to talk about the ratio of their areas. So the ratio of their sides, everybody just said that they were 2. It was 2 to 4, okay? Okay, I'm going to simplify my fraction, reduce my fraction to lowest terms. So 1/2 is the same thing as what? Oh, shoot, I just said it. 2/4 is the same thing as what? 1/2. That's an equivalent fraction. Good. So we're in a ratio of 2 to 4 or 1 to 2. Okay, now what's the area of figure A? Count up all the squares. 1, 2, 3, 4. So figure A has an area of what? 4. Good. Figure B has an area of what? 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. Good. And if we simplify and reduce that fraction, what do we get? 1/4. Okay, good. So I'm going to highlight these two numbers here. 1/2 and 1/4. And we're going to come back to it. Okay? 1/2 and 1/4. Because we're looking for a pattern here, okay? All right. Please draw these two figures. I'll give you a moment to do that. Please make it an accurate drawing, just like it is on mine. Nicely done. Okay, so I'm going to write that down. So we decided that these two figures, figure A and B, are similar. So we're going to say yes. Well, eventually we're going to say yes. We're going to say yes because their side lengths are proportional, and which would be 1 to 3. So let's go over here to my little T diagram here. We said that the ratio of the sides was 1 to 3. Okay. What is the ratio of the areas here? Can you please count up the area in figure A? Yeah, Adrian, give it to me, please.
4 to 36.
Area in figure A, 1, 2, 3, 4. So 4. Figure B, if you count up all those dots, there's 36 dots, right? Yeah. And if we simplify that fraction, reduce it, what will we get? 1 to 9. So again, I'm going to highlight the ratio of the sides to the ratio of the areas. Okay? Just like we did in the last one, we had 1/2 to 1/4. Now we have 1/3 to 1/9, and we got one more to go. We have one more to go. I got figure A, figure B. Last drawing figures. Please put this, make this. It says yes. Why do you say yes?
Because each side is, or for this 1 to 3.
So he says yes, they are proportional because they're similar. Sorry, yes, they're similar because they're in proportion of 1 to 3. Okay, so the ratio of the sides is 1 to 3. What's the ratio of the areas? What's the area of figure A?
4.
Figure is 4. What's the area of figure B? 36. Oh, same thing. So that would be what? 1/9. Okay, so now here's the question. Does anybody see a pattern here? Does anybody see a pattern here? Yeah, Ursula, what do you have? It's just squared. Yeah, it's just squared. So let's go back to the first one here. Look at the top of your page. If two figures are similar, then the ratio of their sides and the ratio of their areas are related. All you got to do to get the area is square the ratio of the sides. So 1/2 squared is 1/4. You guys see it? Same thing over here, right? We found that 1/3 squared is the ratio of the areas, which was 1/9. And then again down here, as long as the figures are similar, the ratio of the sides is 1/3, the ratio of the areas is 1/9. You guys, that's what's going to go in our toolkit. Okay? It's going to look like this. If I can bring. So we should be at the. look at the very bottom. This is the theorem is 11.5. It's called the area of similar polygons. And here's how I said it. I said if the side of figure A is like x and the side of figure B is y, and they are similar, then the area figure A to the area of figure B is just x squared over y squared. All right? So I kind of paraphrase from what was in the book. Yeah.
What's the simplest percent?
One like this. I have two similar figures here. I have two similar figures. It says so in the directions. I got polygon ABCD and polygon HJKL are similar. So they are telling me right away that they are similar, so I don't have to check because it was given to me. So figure ABCD is a smaller one. Figure HJKL is the larger one. And they tell me some information about the side lengths. They tell me that from B to C is 5, and from J to K is 15. Okay. All right. They tell me that C to D is 11, but they don't give me K to L. They tell me that HL is 39, but they don't give me AD. All right, we're going to get all these things, right? And they give me that JH is 27, but they don't give me BA. But of course, we can get all these things, can't we? All right, so let's go ahead and fill in everything that we can around the figures here. What would KL have to be? You can just shout it out. Yeah, KL would have to be 33. Because in order to get from 5 to 15, what do? Multiply by 3. So what's the ratio of the smaller one to the bigger one? 1 to 3. Good. So from 11, we multiply by 3, and we come up with 33. Good. If this one's 39, how do I go back? Divide. Yeah, so what would AD be? 13. Yeah, very good. Good. Okay, if this is 27, what would this side be? Yeah, it'd be 9, right? So I have everything in order, right? So what's the ratio of their side lengths? Yeah, the ratio of their side lengths is 1 to 3. What would the ratio of their areas be? 1 to 9. Very good. And that's the last question down here. So ratio of their side lengths was 1 to 3. Ratio of their areas was 1 to 9. I'll put that back up. Everything else we found. We found this one and we found that one.